Okay, guys, so we're going to do solving triangles using sine, cosine, and tangent. So on Friday, we looked at what sine, cosine, and tangent were. So if you remember, sine is our opposite side over our hypotenuse. Our cosine is the adjacent over the hypotenuse. And tangent is opposite over adjacent. Remember, we had that acronym TOA, and that tells you sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So I have two warm-up problems with you. I'm going to do the first one with you. You guys are going to do the second one on your own. So the first one just says find the tangent of z. So it tells us we're coming from angle z. We need to know that tangent is opposite over adjacent. So we're going to go to the opposite side, which is 21, over the adjacent side, which is 28. Reduce those if you can. So 21 and 28 are both reduced by 7. So I'll give you 3 over 4. As a decimal, that's 0.75. So you need the fraction answer and you need the decimal answer. Rounded to 2 or 3 decimal places, whatever it tells you. All right, so do cosine of c on your own. So what we're looking at today is we're going to be using sine, cosine, and tangent to be able to solve using a trig ratio. So what we're going to be looking at is if you don't know an angle, so for example, we have the same triangle up here, okay, and I know this angle here is 32 degrees, and I know this side is x and this side is 12, we can use opposite over adjacent, so we'd use tangent of 32 to be able to solve for x. So when you're using the trig ratios, it's used to find a missing side. And the reason we can't just use Pythagorean theorem is because we're not going to have two sides. If you have two sides and you just need to find the third one, you could just apply Pythagorean theorem. But in this situation, we're only going to be given two sides. And so there's no way to use Pythagorean theorem if you don't know two of the three sides. So our first example says find the value of x, round your answer to 2 decimal places. So they give us this 32 degree here, and then we have 11 in x. So we have to decide if we're going to be using sine, cosine, or tangent. So from 32, we have the opposite side, and we have the adjacent side. So since we have opposite and adjacent, we're going to do tangent. So we're going to take the tangent of 32 degrees, and that's going to be equal to the opposite, which is 11, over the adjacent, which is x. So what you want to do is you want to get x by itself. So we're going to multiply both sides. You can't multiply by 11, because if you multiply 11, that's just going to give you more on top. We've got to clear the bottom out. So we're going to multiply both sides by x. So that gives me x tangent of 32 equals 11. X still isn't by itself, so to get it by itself, we're going to divide by tangent of 32. So x equals this over here. Well, that doesn't make any sense to me, 11 over tangent 32. So we're going to type this in our calculator. So here's what you're going to hit on your calculator. You're going to type in 11 divided by, and then there's going to be a tangent button, 32. And tangent is somewhere in the middle of the calculator. I don't have a calculator with me, so I can't tell you for sure. But it's in the middle. There's a sine, a cosine, and a tangent button. You'll be able to see them. Type that in your calculator, and that gives you 17.6 something. I don't have my calculator, so I'm just going off what the book gives me. And it rounded to 1 decimal places. So you're going to have an extra one. Do you need something? Okay. All right. So example 2 says find the value of x and y using sine and cosine. Round your answer to 2 decimal places. So in this case, we have 3 sides, but we don't know 2 of them. We don't know x and we don't know y. But they do give me this angle over here, 26. So from this angle, if I want to solve for x, I have x is the opposite of my angle. I don't want to go over the adjacent because the adjacent one is y. So I'm just going to have x over y, which wouldn't help me solve for anything. So I want to go over 14, which is my hypotenuse. So if I'm coming from 26 and I'm going opposite over hypotenuse, that is going to be your sine. So I'm going to take the sine of 26 equals opposite over hypotenuse. So then solve for x. You have to clear out the bottom by multiplying by 14. So we have 14 sine of 26 equals x. Type that in your calculator, and you get that x is 6.1, approximately. So now we have to solve for y. So we need to set up an equation where we take some tangent ratio of, or not some tangent, some trig ratio of 26, where we get y. Well, y compared to 26 is our adjacent. So we have two trig ratios that use adjacent, either tangent, which is opposite over adjacent, or cosine, which is adjacent over hypotenuse. We can't use the opposite side because the opposite is x, and now we know x, so I guess you could use it at this point. But if you solve for x incorrectly and then you try to use it in the next one, then you're going to get y incorrectly. So my advice is to try to stay away from the ones that you've solved for and just use what was already given to you. So we're going to go adjacent over what we were given, which was your hypotenuse. So that means we're going to be using cosine. So cosine of 26 is the adjacent side, which is y, over the hypotenuse value, which is 14. So to solve, we're going to multiply both sides by 14. So y is 14 cosine times 26. Type that in your calculator, 14 times cosine of 26, and you should get 12.6 approximately. All right. I thought this was my last example, but I actually have two left. So we're going to do two more examples. So the first one, it says find the values of u and t using sine and cosine. So this is the same we just did. So it tells you to use sine and cosine. You don't necessarily have to use sine and cosine, but they're not going to give you the adjacent or the hypotenuse. So you're not going to be able to use tangent because tangent needs both of those. So you're going to have to use sine or cosine. So we have 65 degrees over here. So let's say I want to solve for t first. So if I'm solving for t, I'm going to go, I want to do 65 degrees, something at 65 degrees, and I'm going opposite, which is t, over my hypotenuse. Well, which trig ratio is opposite over hypotenuse? Sine is. So we're going to take sine of 65, and we're going to go t over 8. So we're going to multiply both sides by 8. So we get 8 sine of 65 equals t. Type that in your calculator, and you get that t is, hang on, I got to type it in my calculator, 8 sine 65. I got 6.614, but if you're rounding to 2 decimal places, this says nearest tenth, but always round to 2 decimal places. So then we're going to go 6.61, and that's your answer. So now I want to solve for u. So again, I'm coming from 65 degrees. U is over here. That means it's the adjacent. You only have two trig ratios that use the adjacent, either cosine or tangent. Because I don't have the opposite, I want to use cosine. Now, theoretically, you just solve for the opposite side. Like by solving for t, you now have t. You could use tangent, but if you got t wrong, then you're probably going to get u wrong. So always try to use what they've given you in the picture. So I'm going to take cosine of 65, and that's going to be adjacent, which is u, over the hypotenuse, which is 8. Multiply both sides by 8 to clear out the denominator. 8 cosine of 65 equals u. Type that in your calculator. 8 cosine of 65, and it gives me, I must have done something wrong, because it gave me a negative, and I shouldn't get a negative. Eight cosine 65. Hang on. Let me check this is my phone calculator. Eight cosine. I got adjacent over hypotenuse. It's giving me negative 4.49. And I know that can't be correct because we're talking about side lengths, and my side lengths can't be negative. So there's something wrong on this, and I'll just take a look at it, and we'll come back and look at it on Monday. But the other side is correct. I don't know what I did wrong because it doesn't matter. Okay, last example. So we're going to find the value of x. So it doesn't tell me if I'm using sine or cosine or tangent, so I'm just going to have to make that decision on my own. They give me 61 degrees, so I know I'm coming from that angle. From 61, I don't have the hypotenuse, and I know I don't have the hypotenuse because there's nothing across from the 90-degree angle. So that means I have both the adjacent and the hypotenuse. So if I come from 61, the opposite side would be this 22, and the adjacent side would be x. So if I'm using opposite and adjacent, that must mean I have to use tangent. So tangent of 61 is the opposite side over the adjacent. Multiply both sides by x, so you get x tan of 61 equals 22. X is still not by itself, so we're going to have to divide both sides by tangent of 61. So we get x equals 22 divided by tangent of 61, and I get x is 5.877. We want to round it to 2 decimal places, so 5.88 is your answer there. When you're finished with your notes, get the purple sheet, I think it's purple, from the sub, and you can start your homework. And then if you have extra time, work on your homework from Friday or anything else you have for